Okay, hi guys. So this is exciting. We're finally going to do antiderivatives, and this is really like the last like big thing that that we need to know. So notation. Derivative notation. There's a lot of different derivative notations, but here's one. So a derivative notation looks here's one way of doing derivative notation. So d dx, and then in here will be some kind of function, and then it just means to take its derivative. Antiderivative notation looks like this. There's like, this is called an integral sign. It's like an elongated S, okay? And then in here goes some function, and then we put a dx at the end. So if you put a function in here, it means to take the derivative of that function. If you put a function in here, it means to take the antiderivative of that function. Okay, so the derivative, so like, for example, the derivative of ax to the n would look like this, and you'd put ax to the n. It means to take the derivative of that. And then the antiderivative of ax to the n, okay, so there's the antiderivative notation, and then you would just put ax to the n on the inside. Okay, steps to take. So we already know this. If you're taking the derivative of something that looks like ax to the n, first what do we do first? Okay, so first you multiply the coefficient by the exponent. Okay, so it would be a times n. This exponent would come down. And then you subtract 1 from the exponent. So the reason I wrote this out is because to do the antiderivative, we just have to reverse this. All right. So instead of doing, instead of first multiplying by the coefficient, we'll first we're going to subtract. Okay. So anyway, if you want to do this in reverse, like to undo something, you first have to reverse the last step. Okay. So if you want to undo something first, you have to reverse the last step. So first, instead of subtracting 1 from the exponent, we're going to add 1 to the exponent. So that would reverse this last step. And then we need to reverse the first step. So instead of multiplying the coefficient by the exponent, we're going to divide coefficient by the exponent. Okay? Now let me give you the formulas. So if you add this, which means to take the derivative of ax to the n, it'd be a times n x to the n minus 1. All right? But now the formula for the antiderivative of ax to the n is it would be a over n plus 1 a to the n plus 1. Now, guys, here's something that I'll talk about. You have to go C, all right? And I will tell you why in just a minute, but let's go. So I added 1 to the exponent, and then I just divide the coefficient by the exponent, all right? And we're going to get a lot of practice with this. Okay, so why the plus C? Guys, really, when you're finding an antiderivative, what you're finding is a family. You're finding an entire family of functions that has the same derivative. Okay, so let me just do a little demo here. Okay, so for example, like here's a bunch of functions, and then I want to do, like, let's say, let me just switch notation. So I'll do prime. I'll do this notation. All right, say I want to take the derivatives of all of those. The derivative of x to the 5th plus 7 is 5x to the 4th, and then the derivative of a constant is just 0. The derivative of this, x to the 5th plus 9, is 5x to the 4th. The derivative of just x to the 5th is 5x to the 4th. The derivative of this is 5x to the 4th. So here's the thing, guys. If you want to do the antiderivative of 5x to the 4th, so that means going backwards, there are actually infinitely many functions whose derivatives are 5x to the fourth. So when you're doing the antiderivative, the answer is actually a whole family of functions. So we say this. Let me actually use the rule that we just did. So you take 5, that's the coefficient. So I got to add 1 to the exponent. So 4 plus 1 is 5. So I'm going to be dividing the coefficient by 5, x to the 5th. And then we do plus c. C stands for any constant. All right, and then see we get x to the 5th plus c. C stands for any constant, and c could be any number. So when you're finding an antiderivative, you're not just finding one function, you're finding an entire family of functions. So this plus c is very important, and they're going to ding you on the AP test if you don't include it. Okay, so find the indicated antiderivative family. Okay, so yeah, so I add 1 to the exponent, so that's going to be 3. So it's going to be 3 over 3x to the 3rd plus c. That plus c is very important. Like I said, it's a big deal. They're going to ding you if you don't include it. All right, so there's that. All right, now this here, they're asking for the antiderivative of 5x to the 3rd. So I'm adding 1 to 3. That is 4. So it would be 5/4 x to the 4th plus c. Okay, and there's nothing to simplify. Now here, we want to do the antiderivative of the cube root of x to the 2nd. But the thing here, guys, just like with derivatives, you can't do an antiderivative. You know, the first thing you want to do with an antiderivative is you want to try to express it in the form ax to the n. All right, so I'm going to bring down my notation, and I'm going to ask myself, how could I express this in the form ax to the n? So it would be x to the 2/3. Okay, so I just rewrote that antiderivative. And now I'll actually do the antiderivative. So I'm adding 1 to 2/3. I'm adding 1 to 2/3. So maybe up here, or down here, I'll say, like, so 2/3 plus 1 is 3/3. It's 5/3, okay? So our new exponent is going to be 5/3. So it's going to be, so in the coefficient out here is 1. So it's 1 over 5/3 x to the 5/3 plus c. But guys, don't leave it like this. Do keep, change, flip. So keep, change, flip. So 1 divided by 5/3 is 1 times 3/5. So this is 3/5 x to the 5/3 plus c. Okay. Now this one, again, it needs to be of the form ax to the n. So let me bring down my notation. So how could you write that as ax to the n? It'd be x to the -2. Okay. So the coefficient is 1. So it's going to be 1 over -2 plus 1, we're adding 1. -2 plus 1 is -1, and then x to the -1, because we're adding 1 to the exponent, plus c. So that's -x to the -1 plus c. Guys, don't worry, you're going to have a ton of practice. And you want to do all of the practice, because you got to be like just as fluent with going backwards as you are with going forwards. All right, again, not of the form that we want, so I can go 7/3 x to the -5th. So it's going to be 7/3 divided by -5 plus 1 is -4, x to the -4 plus c. All right, and then keep, change, flip on this. All right, keep, change, flip, and you get -7/12 x to the -4 plus c. Okay, and then finally, here's the last one. So this is x to the -3/5. All right, and then -3/5 plus 1, so plus 5/5 is 2/5. All right, so that's going to be the new exponent. And this coefficient is 1. So it's 1 over 2/5 x to the 2/5 plus c. Keep, change, flip. 5/2 x to the 2/5 plus c. Okay, guys, you've got to be so comfortable with these. So here we have, here's your practice, okay? And I'm going to attach all of my work for all of these. All right, I'll attach the answers first so you can look real fast and see, oh, did I get it? And then I'll attach my work so you can see like the process. Find the indicated derivative or antiderivative family. So a derivative doesn't have a family, just a derivative is a derivative. But an antiderivative has a family, which means the plus c. Or when you're finding an antiderivative, you're not just finding one function, you're finding a family of functions with infinitely many members that all have the same derivative. Okay, so I start out just with the top row of just antiderivatives, and then below that we start to mix them up. Now, a piece of advice that I was gonna have you guys do this too. Hopefully, we'll be able to get together again. We will get together again. I'll take you out to dinner when all of this is over. But so in the past, I would have students like write like advice to the next year's calc students, and I loved this one. Actually, this wasn't just a single person. A lot of people said this, but they would say you're going to mix up derivatives and antiderivatives. It's fine. You're going to mix them up. The only way to get over that hurdle is to just practice, practice, practice. Okay, guys, that's all I have to say. I'll talk to you later.